In this film, we're going to talk about the electrical power and energy. A lot of appliances in our daily life use energy from the electricity network. How much energy they use depends on a number of variables which we are going to look at in this clip. On all appliances, you can see how much watt they use. Watt is a unit for energy per time used by the appliance. We call this the power of an appliance. The symbol for power is P and the unit is watt. Watt is the same as joule per second, which is a very useful unit when calculating the used energy. The power of a device can be calculated by multiplying the voltage with the current that goes through the appliance. As an example, we look at the water cooker. The water cooker is connected to a 230 volt socket. When turned on, the current through the water cooker is 9.57 amps. When we want to know the power of the water cooker, we use the formula and fill in the known variables. When calculating, we will see how much the power of the water cooker is. In this case, it's 2200 watts, which is the same as 2.2 kilowatts. Now we know the power of the water cooker. We can also calculate how much energy it used when bringing the water to a boil. We know the power is 2.2 kilowatts, which is 2200 joules per second, and the time it took to boil the water was 5 minutes, so this is 300 seconds. If we multiply those two numbers, so 2200 joules per second by 300 seconds, we get the total amount of energy consumed by the water cooker, which comes down to 660,000 joules, which is 660 kilojoules. So we actually worked out our own formula. By multiplying the time and the power, you get the energy. In a formula, we write it down as the energy equals the power multiplied by the time. When you are painting a room, you want a lot of light. So we can use these lamps with a lot of power. This one has a power of 1000 watts. And we're going to need it for 1 hour, which is a long time. If we calculate the energy needed for this, we can fill in the formula. But we have to use 3600 seconds for each hour. So the total energy comes down to 3.6 million joules. This is a lot and not always useful. So we found out a different way to calculate the energy in a different unit. For the power, 1000 watt, we now use 1 kilowatt. So for every 1000 watts, we write down 1 kilowatt. And the time we do not transfer into seconds, we keep it using hours. If we then fill in the formula, the energy equals power multiplied by the time, we multiply 1 kilowatt by 1 hour, which results in an energy of 1 kilowatt hour, which means kilowatts multiplied by hours. This is the total amount of energy used, and this is an easier number than the 3.6 million joules. In conclusion, we've seen that we can calculate the energy in kilowatt hours, but also in joules, and 1 kilowatt hour is the same as 3.6 million joules. So electrical companies tend to use the kilowatt hour for our energy consumption, since we use a lot of it.